Hello, dearest web interface architects and enthusiasts. Professor Solo at your service. In days of yore, most layout problems did not come from poorly written CSS. They came from the overwhelming need to rely on elegant trickery, convincing the browser to do things it was never really designed to do, and certainly not designed to do cleanly. For a long time, CSS didn't have clear answers to some very basic questions. Who decides direction? Where should alignment and justification be controlled? And what is allowed to grow, shrink, or wrap, and under what conditions? So, we improvised. We laid out interfaces using floats, positioning, clear fixes, shims, and inline behavior. Tools built for text flow, not interface design. They worked, but barely. As interfaces became more complex, navigation bars, toolbars, card rows, flexible panels, those tools started to show their limits. Design needed layouts that could adapt continuously, not snap between breakpoints or collapse under pressure. Flexbox was created to solve that problem, not by adding more tricks, but by defining a model for how a group of elements should behave in relation to each other and their parent container when space changes. That's where the name came from. Flexbox is short for Flexible Box Layout, a system where a container defines flexible rules and its contents respond to available space by growing, shrinking, or reflowing as needed. Boxes that bend instead of break. And the key shift is this: layout responsibility moves up to the parent. The container becomes the decision maker. The children become participants in a negotiation. Direction matters, alignment follows direction, and flexibility is resolved mathematically, not visually. That's what this video is all about. Not memorizing properties, not chasing layouts by trial and error, but understanding the system Flexbox introduced and why it behaves the way it does. Let's start with the single command that turns that system on. Display flex.
All right, team. T.A. Watts here. Buckle up, because today we're talking about the moment everything, and I mean everything, changed in web layout. We're talking about the day the architect arrived and gave us the blueprint for Flexbox. Before Flexbox, seriously, web layout was a total battlefield. We were all living in the dark ages, okay? We were ruled by these clunky things called floats, haunted by clear fix hacks, and the idea of actually centering something vertically, that was basically a myth. You'd have boxes collapsing for no reason, navbars just buckling under pressure, and developers whispering ancient incantations at their screen just trying to get something in the middle. It was chaos. And then the architect arrived. And look, Flexbox wasn't just another CSS property. It was a total revolution. It was designed from the ground up to bring some serious order to all that chaos, to solve those ancient, painful problems of layout once and for all. I mean, just look at this. This is the difference. On the left, that's the old way, a brittle, unpredictable mess of hacks you had to wrestle into place. And on the right, that's the architect's blueprint, a clean, intentional system built on 3 pillars: alignment, flow, and true flexibility. It's the difference between hoping your layout works and knowing it will. And believe it or not, all this power starts right here, with one line of code: display flex. That's it. You add this to a parent element, and you've just transformed a simple box into a powerful, intelligent layout engine. Everything changes the second you type this.
This line doesn't just activate Flexbox. It changes who's in charge. Before, each child sized itself. After, the parent defines the rules. That is the first mental shift you need to make if you want to master Flexbox. Flexbox is a parent-driven layout architecture. If we try to reason about Flexbox from the child outward, we'll fight it and lose. Start with the container. Always.
So to really master Flexbox, you've got to think like the architect. It's all about this metaphor. The container, that's your stage. Its direct children, they're the actors. And the axes are your compass, guiding their every single move. If you can get this picture in your head, the rest is going to click right into place. And here is the absolute core concept, a separation of powers. The container, the stage, gets all the big picture controls. Things like direction, wrapping, and how to align the group as a whole. The items, the actors, they get their own set of powers to follow those rules, or in some special cases, to override them. This division of labor is the absolute beating heart of Flexbox.
This separation is not arbitrary. It's architectural. The container controls direction, wrapping, and group alignment. The items themselves negotiate growth, shrinkage, and starting size. If you remember nothing else from this video, remember that split. Most Flexbox confusion comes from trying to use an item property to solve a container problem, or vice versa.
So, the very first command you give as the architect is setting the direction. Flex direction is your steering wheel. It establishes what we call the main axis, and it tells your items whether they should line up horizontally, in a row, or stack up vertically, in a column. This one decision dictates everything that happens next. And that one decision sets up the two roads your layout will always follow. The main axis is the primary direction of travel. The cross axis is always perpendicular to it. So simple, right? If your main axis is a row, your cross axis is up and down. If your main axis is a column, your cross axis is left to right. Know which way your axes are pointing and you will never get lost.
Flex direction is about how the space in our container is measured and how the flex items are then placed and laid out within it. The moment we set flex direction, we are defining an axis system, a frame of reference for the entire layout. Think Cartesian, not decorative. One axis becomes primary. That's our main axis. The other becomes secondary. That is our cross axis. If our direction is a row, our main axis runs left to right. The cross axis runs top to bottom. If, however, our direction is a column, the main axis runs top to bottom, and the cross runs left to right. Everything Flexbox does from this point on is expressed relative to those two axes. No exceptions and no shortcuts. If you want another mental anchor, think Roman columns. Columns define the vertical structure. The space between them defines the horizontal rhythm. Change the orientation and the rules still hold because the axes move with the structure. So, if alignment isn't behaving, don't reach for another property. Check the axes.
Okay, the stage is set, the compass is pointing the way. Now for the fun part. It's time to actually command the actors and place them on the stage with absolute precision. Okay, forget every painful hack you've ever used to center things. Flexbox gives you two beautiful, elegant levers. Justify content lets you distribute your items along that main axis. And align items handles their alignment on the cross axis. With just these two properties, perfect centering isn't a myth anymore. It's a two-line solution. Done.
Think airport runway. Planes move in one direction. That's our main axis. Spacing between the planes along the runway, that's justify content. Now, look across the runway. Planes can sit left, center, or right within their lane. That's align items. Same planes, same runway, different axes. And here's how to make this concrete in DevTools. Inspect a Flex container, turn on the Flex overlay. The browser will draw the axes for you. Change Flex direction and watch the runway rotate. Change Justify content and the planes move along it. Change Align items and they shift across it. So don't ask, why isn't Align items centering this? Ask, which direction is my runway facing? Flexbox is brutally consistent. It only feels unpredictable when we lose track of the axes.
All right, now let's talk about that flex part of Flexbox. What happens if there's extra room on the line? Well, that's where Flex Grow comes in. Think of it as an item's appetite for empty space. It's just a number that tells an item how much of that leftover space it should eat up. By default, it's 0, so items are pretty polite. They don't grow at all. And the opposite? What if space gets tight and things start to feel cramped? Flex Shrink takes over. This dictates how willing an item is to get smaller to make room. The default is 1, which means all the items basically agree to shrink down proportionally. But if you set it to 0, you're telling that item, nope, you hold your ground, don't shrink. So what size do they even start at before all this growing and shrinking? That's Flex Basis. Think of it as an item's opening offer in a negotiation. It's their ideal size on that main axis before any of the flexibility calculations even begin. It is the starting point.
Flexbox is about flexibility, but not in a vague sense. At its core, Flexbox is specifically built around the concept of proportional flexibility. Flex items don't have rigid sizes. They start with a preferred size and then negotiate space relative to one another. Flex Grow is proportional. If one item has a grow value of 2 and another has 1, the first gets twice as much of the available space. Flex Shrink works the same way, but in reverse. When space is tight, items give up space proportionally, unless we tell them not to. Flex Basis is the starting point, the size an item wants to be before any of the negotiation begins. Flexbox isn't guessing. It's doing the math to keep things in proportion relative to each other, given a calculated amount of available space. We used to have to write JavaScript functions to do these calculations. Now, it's handled directly in CSS, out of the Flexbox.
Now, in the real world, you're almost never going to write these out individually. Instead, you use the Flex shorthand. This is it. This is the complete deal you make with each item, defining its growth potential, its shrinkability, and its starting size, all in one clean declaration. This one property defines an item's entire personality in the layout. Okay, a single flexible line is incredibly powerful. But let's be real, the world is messy. Screen sizes are all over the place. So now we're going to level up and handle layouts that need to break, bend, and flow across multiple lines. So picture this. You've got this beautiful, flexible line of items. The browser window gets narrower and narrower, and then what, right? What happens now? Do things just fall off the edge? Do they break? Do they get squished into nothing? Well, by default, they try to cram onto one line, which leads to that ugly mess you see on the left. But if you add one simple rule, Flex Wrap Wrap, your layout becomes truly responsive. Now, items that don't fit just gracefully flow onto the next line. The layout bends instead of breaking. It's beautiful.
Okay, I've got to say it. That layout on the right wasn't the most beautiful example of wrapping. That said, Flex Wrap is how Flexbox responds when flexibility runs out. As long as there's room, items negotiate space along a single line. They grow, they shrink, they compromise. But eventually there's a limit. At some point, shrinking further stops being useful. Wrapping is the signal that says, stop compressing, start flowing. When FlexWrap is left at its default, Flexbox will keep forcing everything onto one line, even when that means crushing content or creating awkward layouts. When we enable wrapping, we're giving the system permission to create multiple lines and to redistribute items across them. Once again, this is a structural decision. Now, let's clear something up before anyone gets too clever. No wrap, the default, has no dash. Not no dash wrap, not today, not ever. And flex wrap is not a Boolean. This is not an on or off. It is permission. When we say wrap, we're not flipping a switch. We're telling Flexbox it is allowed to create multiple lines. And then there's wrap reverse, which does have a dash, and its use case is rather unknown. Wrap reverse wraps, it just flips the cross-axis stacking order like a chaos gremlin. There are very, very few use cases, and usually they're strictly visual, like if you're building a bar chart. That's a wrap on my FlexWrap wrap. Quick, change the topic, T.A. Watts.
And of course, once things are wrapping, you need some space between them. In the old days, this meant these terrible margin hacks that always caused problems. Forget all of that. Just use Gap. It creates clean, consistent spacing between your items and only between them. No more fighting with weird, unwanted space at the edges of your container.
This one's super simple, but equally important. Margins describe relationships from the outside. Gap describes relationships within the system. Flexbox layouts behave much better when spacing is expressed at the container level.
Okay, lean in for this one because this is the property that gets everybody. Align content. This does not align the items. Let me say that again. It does not align the items. It aligns the entire group of lines. It only kicks in when you have wrapping enabled, you have more than one line of items, and there's extra space in the container. It controls how that whole block of content gets positioned.
Think of this one in terms of a highway system. Traffic flows in one direction. That direction defines the main axis. Each lane of traffic is a flex line. When wrapping is enabled, we don't have one lane, we have multiple lanes running in parallel. Align items controls how cars are positioned within their lane. Align content controls how the lanes themselves are positioned across the highway. Closer together, spread apart, centered as a group. And here's the rule that really matters. Align content always works on the cross-axis, and it only applies when there are multiple lanes and extra space to distribute.
All right, we're in the home stretch. You have the core tools of the architect. Now it's time for some advanced wisdom, the rules of engagement for using Flexbox with precision, with power, and with responsibility. The order property can feel like a superpower. It lets you visually re-sequence your items without ever touching the HTML. But, and this is a huge but, here's the critical warning. Screen readers and keyboard navigation, they follow the HTML order, not what you see on the screen. If you reorder content with this, you can create a totally confusing and inaccessible experience for some users. Use this tool with extreme care.
For this one, think of an elevator in a shopping mall. Instead of listing floors numerically, the buttons might be grouped by destination and then listed alphabetically. Cinema, clothing, electronics, food court. Visually, that makes sense. It helps people find where they want to go faster. But in reality, food court is on the first floor, cinema's on the second, electronics is the third floor, and clothing is on 4. The elevator itself still moves to the correct floor by number. It follows the building's structure, not the labels on the panel. What does this have to do with Flexbox? Well, by setting the order property on Flex items, we can rearrange them visually to make an interface clearer or more convenient. But the document's logical flow, the DOM, remains unchanged, and that is what keyboard navigation and screen readers are going to follow. When we change order, we're intentionally creating 2 representations, one optimized for visual scanning and one that reflects the true sequence. That can be the right decision, but it is always a decision. One useful rule to remember: if changing the order changes how the content is understood, that change probably belongs in the HTML. Flexbox gives us the freedom to reorganize items, but we're still responsible for how that affects information architecture and accessibility.
And finally, the big question you're all going to ask. When do I use Flexbox and when do I use Grid? The rule is actually super simple. Flexbox is the master of one-dimensional layout. It's for controlling a single row or a single column. That makes it perfect for components like a navbar or a row of cards. Grid is for two-dimensional layout, controlling rows and columns at the same time. It's for the big picture, the overall structure of your entire page. So we've covered the theory, we've covered the properties, the pitfalls, the whole philosophy. Now let's see what happens when we put it all together and watch the architect's blueprint come to life. And that's the blueprint. The architect's tools are now yours. You can guide the flow, you can control the alignment, and you can build layouts that are responsive, robust, and truly intentional. You're no longer fighting the browser, you're conducting it. So the only real question left is, what are you going to build? Handing it back to you, Professor Solo.
There we go. That's Flexbox. Flexbox as a system. We know how direction defines axes, how alignment and justification work with those axes, how items grow, shrink, wrap, and negotiate space, and how all that visual power also comes with some responsibility. Flexbox is the tool that we reach for when we're laying out items in a single dimension, be it a row or a column. Nav bars, toolbars, card rows, UI components that need flexibility without fragility. Any component that needs to flow, adapt, and stay resilient. One-dimensional power tool Flexbox unlocked. But what about when we care about both rows and columns at the same time? When the page itself needs a blueprint, beyond just adaptable, flexible parts. That's where Grid comes in. Grid doesn't replace Flexbox, it complements it. Flexbox handles the flow within our components, and Grid defines the structure between and around them. We've brought Flexbox into line. Next, we'll zoom out to full page view and start building in 2 dimensions. I'm Professor Solo. This is WebDev TnT. If this has helped sharpen your understanding, subscribe and stick around. There's more architecture ahead. P.S. Keep learning.